Okay, so welcome back welcome to second semester. This is just a review of some skills that we should have, or at least be aware of from the first semester that we want to refine a little bit. So let's go ahead and look at these. We'll work through them. If you're watching the video, I'd recommend you stop and give them a shot, see how it goes. But magic of television. Here we go. So the first one, we're just asked to find the derivative, right? We have y equals 2x squared minus 8x plus 9. Walking around, I think you all had this one, right? This is so we could say dy over dx, or you could say y prime. We're going to get 4x minus 8. Good? All right, got it. Let's do the second one here. We have y equals the square root of 4 minus x. Hopefully you remember, it seems like a majority of the time, if you see a square root, you're going to replace it with a 1/2 power. So with this, let's rewrite this as 4 minus x to the 1/2 power. Okay, and then at this point, we just need to use our chain rule. So we're going to start from the outside, work our way in, right, like peeling an onion, or whatever. So y prime, we'll put the 1/2 power goes out in front. We reduce the power by 1, so it becomes a negative 1/2. And then don't forget to take the derivative of 4 minus x, which the derivative of 4 is just 0, but the derivative of negative x is negative 1. So that'll be times negative 1. It would be okay to write this as y prime is negative 1/2 with 4 minus x to the negative 1/2. Or if you wanted to make it look more like the original, it was a 4. On my key I wrote a 9 because I'm sloppy apparently. And then y prime would be, you could say negative 1 over 2 times the square root of 4 minus x if you wanted to. So either one of these would be fine. You probably should clean this one up a little bit there, right? You have a negative times a 1/2. We good there? Yep. All right, the third one we had is y equals 2 over the square root of 9 minus x squared. I was very happy to see that I didn't see anybody that just rewrote it as 3 minus x by doing a square root illegally, which is good. So, now with this, if you did the quotient rule, you can get the answer, but you have to do a lot of unpleasant simplifying. It really makes it difficult. So what you want to look at this is if you ever notice that you just have a constant as your numerator or a constant as your denominator, then you don't need to use that. You don't have to use the quotient rule. We want to take the time to rewrite this as 2 and then 9 minus x squared to the negative 1/2. This is a much easier derivative to take. Okay, now, if you did the quotient rule, it's not a bad exercise to try to simplify it to get the same answer we're going to get, but it's not easy. And a lot of students that try it don't get it. They kind of peters out if something goes wrong. So with this one, to find the derivative, so dy over dx, it will be 2, which is just a constant multiple, times negative 1/2, and then 9 minus x squared to the negative 3/2. And then we need to take the derivative of 9 minus x squared. The derivative, and it's going to be multiplied. The derivative of 9 is just 0. The derivative of negative x squared would be negative 2x. Okay, so now at this point, we have a 2 times a 1/2. Those will cancel. We have a negative times a negative. Those will cancel. So let's see, dy over dx would be, you could say 2x 9 minus x squared to the negative 3/2 would be fine. You could also, if you wanted to move it to the denominator, 2x over 9 minus x squared to the 3/2. And really, either one of those forms would be fine if you were just asked to find the derivative. You know, sometimes I don't know, if I had to find the second derivative, this would be easier for him to work with. If I was asked about, where the derivative does not exist, this would be easier for him to look at. It just kind of depends on the question as far as what you want to look at or what you want to use. Number 4 was y equals, is it e to the 2x? E to the 2x. So if you remember, hopefully, e was the simplest derivative to take, right? The derivative of e to the u power is just e to the u again times the derivative of whatever u was. So just you have to apply the chain rule still, like anything. So for this one, to find the derivative with respect to x, we're just going to get e to the 2x times the derivative of 2x, which is just 2. So then the derivative of y with respect to x is 2e to the 2x. Okay, so here for numbers 5 and number 6, we're asked to find the x values with the horizontal tangent. So again, this is talking about the original function, in this case f of x, right? There's tangent lines at every point on that curve, or I guess it's a sort of cubic, right? But at some points there may be a tangent line that's horizontal. Right? And we know that the way to find the slope of the tangent line is to find the first derivative. Right? So what we're going to do for this process is, when you see this, you probably want to think, find the first derivative, set it equal to 0, solve for x. That's going to be the process here. So for this one, our first derivative, so f prime of x is 3x squared minus 2. Make sure you get your derivative correct. Would be a good start. And then to find the horizontal tangents, we're going to take 3x squared minus 2, set it equal to 0. Okay, so with this, add 2 to both sides. Divide both sides by 3. So we get x squared equals 2/3. Square root both sides. I had x equals plus or minus the square root of 2/3, which I guess we could rationalize it. I was being lazy and just left it like this. Now, what I did do to check this work, because I'd hate to show you what was wrong, is I typed this function into the calculator, and I think it's under calculate like 6, the dy dx. I did that, and then I input, the square root of 2/3, and it showed me the slope was 0, or some. It had some decimal times 10 to the negative 6 or something, which is essentially 0. And then I did it for the other way. It's just a nice way to kind of check your work with your calculator as you're going. And again, using that derivative function key on your grapher. So that was 6, or that was 5. 6, we have that f of x equals x over x squared plus 1. Unfortunately, this is not, we can't rearrange this to avoid the quotient rule. If it was the inverse, you could put each thing over x and that would help, but it's not going to happen here. So we're going to want to use our quotient rule. So just to review that, we have that f prime of x will be vu prime minus uv prime over v squared, where u is the numerator, v is the denominator. So if u is equal to x, u prime would be 1. And if v is equal to x squared plus 1, then v prime would be 2x. Okay, again, if you're really feeling confident, you might just start writing right away. But if you're at all having trouble with them, it's really useful to write your little pieces out there first. Okay, so then from here, f prime of x will be x squared plus 1 times 1 minus x times 2x over x squared plus 1 squared. So then as we kind of clean this up here, we get x squared plus 1 minus 2x squared over x squared plus 1 squared. And then f prime of x will be 1 minus x squared. Or you could have said negative x squared plus 1 if you wanted to. But this would be the derivative function. Now, it did ask about horizontal tangents, so we're not done. Again, always good to go back and make sure that you actually answered the question that was asked. So we want to know when this, so basically when is 1 minus x squared over x squared plus 1 squared equal to 0 is the question we're trying to answer. Now, thinking about rational functions, we don't really care what's on bottom, because if the bottom ever becomes 0, it's undefined, right? That's not going to create a horizontal tangent. That's going to be undefined. If we have a single fraction, all we care about is when is the numerator going to equal 0. Because whenever the numerator equals 0, you get 0 over hopefully a non-zero number. We should probably check that, but right, we should get the answer we want. So you can essentially just say when is 1 minus x squared equal to 0? Well, that's when 1 equals x squared, and that's when x is equal to positive or negative 1. Now, it is good to go back and check. Either one of this denominator is always going to be positive, right? You're squaring a number and adding 1. That's a recipe to guarantee a positive answer. Okay, so for 7 and 8, we're given a function, and we're asked where the derivative function does not exist. Okay, so where is it not differentiable would be another way that you could write that. Now, really the things we want to look for is basically the domain of the original function and the domain of the derivative. Okay, so if there's not any restrictions that the original function have will carry on to the derivative function. Okay, it's never like, you know, here, 0 fails here, correct? Like 0's out of the domain. So I know automatically that any derivative of this function is not going to be differentiable at 0. Right? It has to exist. If you remember when we defined if it's differentiable, it had to have a limit, right? Or it had to have a value. So if it doesn't even have a value, we're in trouble. So with this one, if I look at this original function, this domain, now algebraically you could do an inequality and things, but if you think about it, this is underneath the square root is a parabola that opens up, correct? And it hits the x-axis at negative 1 and 1. And everything outside of those are positive, which we're good taking square roots of positives. Everything between negative 1 and 1 is negative, which you can't take the square root of a negative. So that means that our domain here would be from negative infinity to negative 1, and then from 1 to infinity. Right? And now what you can do, again, you could solve a quadratic inequality, but I don't really want to do that. Just figure out where the zeros are at for that inner piece. They'd be at negative 1 and 1. So we see that if we put numbers like negative 4 in here, we get an answer that's defined, correct? We see if we put positive 4, we get an answer that's defined. We see that negative 1 and 1 will give us a defined answer, but we see 0 is going to fail. Right? 0 squared minus 1 is negative. So here's the domain of the original function. So we know at a minimum, the derivative does not exist on this domain. Okay? Now let's find the derivative function. So let's rewrite this as x squared minus 1 to the 1/2 power. Here I think domain's easier when you see the square root, because you realize, hey, it's a square root. 1/2 power is a square root. It just doesn't look as much like one. So we get f prime of x is 1/2 x squared minus 1 to the negative 1/2 times 2x. The 2's cancel. And I'm going to go ahead and actually write this using the square root. X over the square root of x squared minus 1. So let's think about where this would be defined, this function. Again, this domain carries through, and there's the same radical, so it would carry through anyways. The question here, is there any additional restrictions that this function has that the original function does not have? Anywhere where it fails to exist where this did exist? I'm asking because there is. So what can we never divide by? 0. So while -1 and 1 produced a defined solution here, right? It gave you 0 as an output. If you get a 0 as an output in the denominator, that's undefined, correct? So it's the same restrictions with the exception of -1 and 1. So we could say that, again, this domain would be -1 to, negative infinity to -1 union 1 to infinity. We just didn't include, went from like a half closed interval to an open interval. It's just those 2 points that goofed up. So we could say f prime of x does not exist. You'll see DNE as an abbreviation. When, let's see, x is contained from -1 to 1. Right? So anywhere from -1 to 1, the derivative does not exist. And that implies everywhere else it does exist. So again, no new like derivative skills here, but kind of looking at the answer differently and seeing how it works. And we're about to run out of time. This is a little bit of a trick question. Are there any domain issues here? You take the sign of anything, correct? So this domain would be that x is real. If you take the derivative, you get the cosine of x. Any domain issues there? Nope. So that would be that x is contained in a set of reals. So we would say f prime exists of x exists for all x. Right? It exists everywhere. So great job today.